All right, welcome everyone. Welcome to the September 3rd or 4th, depending on where you are, Gen3 Community Forum. My name is Michael Fitzsimons, Director of Research Programs here at the Center for Translational Data Science. Um, and today I'm excited to bring to you this community forum, which is a bit different than we normally do. Typically, we like to highlight experiences from across the community, and those are great events. But in the case of this one, we're going to do a deep technical dive into a particular topic that comes up often from our users. We will admit that it is not as documented as we would like, but this is an effort to solve that issue. This is the ETL step, and I'll get into when that happens and why. But suffice it to say, it's needed for displaying the data in the exploration page, as stated here in the title. I'll give a very short introduction and then pass the baton on to my colleagues Dan Biber and Sarah Volte Garcia, who are going to do the majority of the presentation. Okay, so what's the agenda? I will do my best to set the stage with a one slide of data submission overview. And then Dan and Sarah, I think Dan for the first several bullets and then Sarah for the last part on troubleshooting, are going to share how to run an ETL in Gen3. So initially the data model, ETL mapping, and searching for data, how these are all connected, how to create the Elasticsearch indices for the microservice Guppy to use, a review of the demonstration data model, ETL mapping types and subtypes, and then finally, how to troubleshoot your Gen3 ETL. Okay, so what I wanted to do before I pass it on to Dan is just lay out what the overall kind of submission workflow is from data all the way to the exploration page, which is the focus of today. So this is basically getting your structured data into Gen3 and searching through it in the front end. So what is necessary to accomplish that? So this is the 10,000 foot view. And so hopefully you'll be able to see how ETL fits into this. So there's a couple colors here. The gray person here is the Gen3 operator. So that's CTDS or many of the folks on the call here when you're setting up your commons. There's a data contributor here. So this is maybe a sponsor or somebody that comes with data that needs to be searched or distributed in the commons. And then there's a Gen3 user or a researcher who's querying the commons or looking for data. So you start with some data. The Gen3 operator, then usually in collaboration with the contributor, is creating a data model in order to display the data, make it searchable. So we've done topics on this. This is also, there's some steps involved here, but we're not going to talk about it today. Just to say that you've successfully created your Gen3 data model. Um, and you have also done whatever data cleaning is needed to submit it. So this might also be a collaboration between the contributor and the operator. It's often both parties that sort of participate in that step. This is done really outside of the commons. And again, not going to cover it today. So the first step in getting the data in is submitting it through the service Sheepdog. This is submitting it to our graph database that we talk a lot about. Um, at this point, a Gen3 researcher can do API requests via Peregrine. So this can be using a tool, the API, or the query page, but basically you're querying the graph database at this point. However, this data is not what is used to serve the front end, and that's really the crux of today's topic. It's something that is often not realized. You may think, oh, I submitted my data and I'm ready to configure the front end, but there's this critical step here called ETL, or extract, transform, and load, and it is basically taking the data from the Postgres database and loading it into Elasticsearch indices. The reason you need to do this is not just because we wanted to add another step, but is because it makes the front end much more performant. And Dan will get into, I think, why that is, but it is necessary to make the queries fast in the exploration page. So the rest of the talk is all going to be about this box. So how to get the data from the Postgres into the Elasticsearch indices. There's a lot about this, and they put together a great presentation to cover this. But then just to complete the process, uh, at this point, you can also do API requests to Guppy. This can be on the query page or just through a direct API query. There's one more step, configuring the front end in order to make the data available on the exploration page. I think we'll have another topic on this later. It's not as complicated as the ETL, but it is important, and so we'll probably cover that at a later date. So um, this other avenue here, just to highlight, if you do want files available in your exploration page, you're also submitting data to IndexD and also to Sheepdog, some metadata about the files. So sort of these two avenues come together in the exploration page where the users are then building cohort, finding files, and downloading data, and also exporting to the workspace. Okay, so that's the, as I said, 10,000 foot view. Happy to turn this over to Dan and Sarah. Just mention also that we have, they know a lot about this, but we have some additional colleagues on the phone to also participate and answer questions that have come up. In particular, Mingfei Shao, developer, and Chris Meyer, who's the director of user services. So with that, Dan, I'm going to try to stop sharing. Head over to you.
Awesome. Thank you. Okay, so as Michael said, my name's Dan Biber. I've been with the center for 3 years now, and I think like a lot of users, ETL has been a black box for me for quite some time. So I thought I'd take it upon myself and learn this black box, and through my trials and tribulations, share them with the community. So. Going from Michael's 10,000 foot view and winnowing down just a little bit, I'm going to give you another diagram, but essentially to say search on the exploration page directly results from ETL mapping. And that concept here through the blue arrows kind of maps how that works backwards. So from our exploration page, we control Guppy queries. So the exploration page is just, from kind of a technical perspective, a collection of Guppy queries that then throws it into our front end. These Guppy queries pull data from Elasticsearch indices. Those indices are created by our ETL mapping, which that ETL mapping is directly resultant from our relational database, Postgres, or if we're going to say it in like a microservice, Sheepdog, which our Sheepdog database is structured from our data model, right? So that's kind of a big, long, convoluted flow backwards. But like Michael was saying, I'm going to share why we're doing that. Essentially, we could run things all with SQL queries, but as data grows, as complicated joins are made, it's very likely that you're going to run into issues that I'm sure computer scientists are going to know a lot better than me. Why exactly we're going to run into performance issues, but by flattening things in Elasticsearch, we can make it much more performant and not lose users on that exploration page as they build cohorts, as they do kind of faceted search that's needed to interact with data, and the big type of medical data that Gen3 is known for. So, what does that end up looking like at the end of the day? We've got here an example from MIDRC, which is the Medical Imaging Data Resource Center. This is one of data commons that Gen3 manages. And here we see an Explorer page with these tabs. It's enough to say that each of these tabs has an Elasticsearch index created by ETL underneath and supporting it. And Explorer is showing that and allowing users to interact with the data that is all the way back up in your kind of structured with your data model and in Sheepdog, but flows forward into the Explorer and is interactable in that way. So, in microservice language, what are we talking about? We're talking about the microservice tube. Tube contains ETL, and this is the microservice that allows this traversal of the graph database, transforming it and throwing it into indices that are then queryable by Guppy and shown in the Explorer. Again, we use this so that it is performant, so that we've always got these, this direct specific set of indices that are pre-compiled that we can search across. Yeah, so the front end can be usable by exactly that, our users. So, to hammer the point home, right, inside tube, then we've got this, centralized, the central file, the ETL mapping, which if you're using Helm will be in your values YAML, but has been historically called the ETL mapping file. And this is what does the heavy lifting of informing exactly what tables we grab from in Postgres to then carry forward and create indices. This is another diagram that we'll look at. Here we've got, let's start using my pointer here. Tube is that microservice containing ETL, right? It's informed by a couple of different files that you configure, both your data model, as your data dictionary or just dictionary here, as well as your ETL mapping. Tube, this is the kind of the technical document, right, is going to fire up an Apache Spark cluster, where inside that cluster, Scoop, SQOOP, interacts with your Postgres database, pulls data into Hadoop file storage format, and then pushes that into Elasticsearch. So I realize I've been doing, lots of talking, probably, too fast. So I left myself a note to pause for questions. Does anybody have questions or, need to interrupt for clarifications?
I
We
have a
can,
question.
yeah.
Sorry. So for the Explorer page, it's just calling through Guppy to get indices from Elasticsearch. So that means potentially you could have other data that doesn't conform to the data model, Gen3 data model to display on the page, front-end page.
That's a good question. I know for sure that we can, go through, in the route that we've specified, Sheepdog on through to Explore, but I imagine you can. Could we have, Mingfei, does that sound like a possibility? He's on the
Yeah,
call.
right. Mingfei Shao here. That's definitely possible. So ETL, what we're talking here is about how to use the data in Elasticsearch to power the front end, especially, the Explorer page. Because that page basically talks to Guppy and get the data from Guppy, which Guppy helped to get from Elasticsearch. So if you are capable of, or if you are willing to implement your own ETL pipelines, so to say, that someone can get your data into Elasticsearch and be able to serve by Guppy, because Guppy needs some extra stuff, like if there is a array field in the Elasticsearch, Guppy is expecting to see a special configuration index that have those field names in it. So Guppy will be able to know those fields are array fields. So Guppy can, can deal with them, so to say. But suppose that your own handcrafted ETL pipeline /2 / whatever can do that, can produce a result that Guppy can eat, then there's no problem for the front end to use it.
Okay. So there's actually some Guppy configuration that Tube kind of takes care of when you use Tube to generate or transform the data. But if I do something my own, then that's something I have to consider. Okay, thank you.
Yeah. Essentially augmenting onto Tube, your own, specialized pipeline. So thank you, Mingfei. That was helpful for me to understand as well. Other questions before we carry on? Next, we're going to be, looking at some of the specific, configurations of the ETL mapping file. Okay, we can get into that. So the ETL mapping file is a YAML-based schema. You can see here I've got kind of a broad example that shows we're going to start new concepts with a dash, and we're going to preserve those concepts through the same indentation. So, this could work for many different types of mappings, but essentially what we have here is we have we're building an index that we've named my data commons subject. We'd have attributes of that index, props, and we could do additional sub mappings, but you can see that we've got that indentation. Also, with these additional sub mappings, we can chain together multiple props, multiple sub mapping types and mapping types under a single index. And in that way, you can combine and, the power of ETL can be, more or less revealed by chaining together and combining all of these various different mapping types. And that's how you would do that, is with these, these dashes and indents to kind of contain those indices and, sub indices together. So we can get into, I guess I forgot to give some of the throat clearing for all of this, which was, and Michael alluded to it, right? We've got a need to engage the community on ETL mapping. So, to kind of triage, we've got this presentation where, we want to, meet users where we've kind of been gauging they're at. So starting kind of at a 101 ETL 101 and build on from that. So technical documentation will be coming, more robust technical documentation will be coming. But standing in the gap is this presentation. I've got lots of examples which will have the slides available, as well as a lot of these code snippets that you're seeing will be individual files that you'll be able to pull pull from and, inject into your, ETL mapping section, wherever that is, and build your own, that sort of thing. So we're going to give, I'll give terms, so we can start to build that ground knowledge and then carry on from there. So one of those terms is mappings. We've got two main types of mapping, aggregators and collectors. And for each of those mappings, right, you need to specify a name. And this is the name that Elasticsearch is using to call the index. Then we've got the doc type, which this doc type is what Guppy will use to query the index. Then we're going to specify a type. In this case, this top index is an aggregator. This bottom one be a collector. And then in the case of an aggregator, we're going to specify a root node, which is to say in Postgres or in Sheepdog. When I say node, you can think of that as a table that will contain all of your data. For a collector, we've got a category, which instead of a single node or a single table in your Sheepdog database, this would be a collection of a similar type of node. So like a common one would be all of your data file nodes, and a similar properties across those nodes. So that's mappings. I'll go through a couple more terms and then I'll pause again. So we'll do props, and then I think up next will be functions. So we'll do props and functions. So for props or properties, these are fields that are expected to be in the final Elasticsearch index, but will be generally are coming from columns in nodes. So we've got a short code snippet here that is to do with gender, probably in like something like a demographics node. Again, we're specifying a name. This is the name for Elasticsearch. So Elasticsearch is going to be searching for this character string, participant gender, but specifically looking for its source in Sheepdog. That string will be gender. It's looking for that gender property or gender column. And then, because it kind of fits best here, and I didn't find good examples later to talk about it, value mappings is worth mentioning here. You're not stuck with the data you have in Sheepdog. You can actually map that. So if let's for instance say you've got in Sheepdog demographics that are simple characters like F for female, M for male, you can transform those. You can map those F into female in the index and M to male in the index. So you can use those for props. Last one before we pause, talk about functions. So in ETL, you can use these for aggregators or collectors, and these functions can be added to props to count how many nodes have values, used to generate a max value, also a min value. We can sum, which is good for reporting, integers that you have in Sheepdog, as well as list and set are kind of two sides of a different coin. In that a list you can get your full list, including duplicates, and set would be the unique set, minus duplicates. So, questions from there on these terms? We'll break into examples after this. No? Okay. So we've got two main mapping types. We've got aggregation and injection. Aggregation you can think of as traveling from a single root node and aggregating data as you go along. A classic example is like a case aggregator or subjects, where you're going to collect clinical data from that and push it, collect it into that case. So things like, trips to the, events that have happened to that subject, like trips to the hospital or their demographics. The other type is injection or a collector. So we're going to take a class of nodes or a category of nodes and gather data of shared properties on those nodes from parent nodes. A classic example is a data file collector, where we're going to collect data from properties on many different files. And let's say we'd inject something from a higher level parent node like study ID or project ID and put that right next to our data file properties. We have many different aggregation subtypes for aggregation. There's only one for collector, so it'll be quick to go through the collection, but we should spend a little bit of time talking about mapping subtypes for aggregation. If you have a root node in mind, root table, flattened properties is getting properties from nodes below it. Parent props are getting properties from nodes above that root node. Nested props, multiple properties and multiple nodes from lower up into that root node. Aggregated props for adding statistics. Joining props, this one is a little different in that joining props needs created indices. Instead of just dealing straight with nodes, you're able to join created indices in ETL. Sorry, I'll get my cursor out of the way. So let me slow down. That's the aggregation mapping subtypes we have. We've got the collector mapping subtype, which really is just injecting, which I've kind of covered quickly, but is to be able to inject properties from higher up in the graph or the database down into nodes of a category. So I will get into examples now. These examples I've put together based on a example data model. It's very stripped down, almost as simple as I could make it to give good, rich examples. But each of the slides will contain, after we've discussed the data model and I've given you a chance to digest it, we'll have that data model, a smaller version of it, the nodes we're dealing with, a code snippet exemplifying how you'd put together that ETL mapping, and then an example index. Sometimes it'll be a data table because that's really simple in how my brain works. And when it's a little bit too complex, it'll be a JSON. So here's the example data model. You can see I've got 3 different colors here that correspond to node types. First type is just an administrative node type. We've seen lots of questions, do program and project have to be included? They do. With base Gen 3, those are a critical part. The most numerous node type here is just a subject node. And then the last is a data file node type. So doc type is not, so doc type that we were talking about for Guppy to be able to query an index is not directly tied, it's not one-to-one with node type. Just wanted to make that note. So here's our first example. Like I was saying, and we'll go, fairly slow through this one, but we'll pick up speed as it'll be easy to go back through once you've kind of got the layout for these, if you've got specific questions on these mapping subtypes. So first we've got flattened props, which is, arguably, at least in my mind, one of the simplest subtypes of an aggregator, right? Where in this example, we've got subject as our root node, right? And we're going to call this index, and I guess we'll go line by line. We've got these 2 nodes, subject and demographics, where we're going to flatten demographics into subject, certain properties from demographics into subject. So we'll name the index simple flatten, right? Our doc type will be subject. This is what we're going to use to query. Guppy's going to use to query. This is an aggregator type index, where our root node is subject. And we're going to pull submitter ID out of subject into this index. Here's our sub mapping type, flatten props. which is an aggregator type, where we create this, index subject demographics, which has a path to demographics, where our props age and race will be pulled in and flattened. And here's our example index, where we've got demographics flattened into here, 2 different subjects. So I guess I'll leave a quick pause before I, smash through the rest of the examples. Pause for questions, pause for, processing time, that sort of thing. Okay. Well, good. That's makes me happy enough to know that, I don't have 1,000 questions. Feel free to interrupt if you've got them, needing to pause, that sort of thing. So,
Dan, sorry to
Yeah.
interrupt. Just a quick time check that we're aiming to pass along to Sarah for the troubleshooting section at 4:20-ish. So
okay, I've got 15-ish minutes. Yes, we can work through these examples. Like I was saying, the things will start speeding along. With flattened props, you can have a 1-to-1, which to demographics was, very simple. One subject is going to have one set of demographics. Something like a many to star, though, we can have many events per subject, and you can still flatten that sort of data, but you need to sort it. So here you can see with events flattening into subject that we do need to sort. And in this case, we're still going to get a single row per subject, but it's going to sort it by a descending date. So we'll just get back these, the most recent dates for these, for this index. Next up would be parent props, where we're going to pull data from higher in the graph down. So our root node is still subject, excuse me, but we're pulling data up from study, and specifically the prop data batch. Same 2 subjects, but we've got a parent prop in the index. Getting a little bit more complex, you can see here I don't have a table. I've got some JSON. If we want to travel from subject on down to data file, we need to nest these properties. So our root's still subject, but we're going to travel down to sample and then down to our data file image to be able to put together these nested indices, subject, sample, data file, with the props contained. But we don't necessarily have to, with nested props, travel, some of these graphs get very long and there's, many levels. You can skip nodes with nested props. And now is a good time to pause to talk about this pathing. With this path, you're going to be using these node names and delimit them with this period. And with this period here, we're going to path straight from sample down to data file image. And our example index then will cut out what we had before, which was information or props from sample, and skip right down to the file information. So that's nested props. That's one that you're going to be using, quite frequently. Is quite powerful, especially if you've got a complicated sheepdog database. Aggregated props. Here you can see we're going to be counting the number of samples per subject. So our root is subject. We're going to be pulling some data from sample, but also then the sample counts. Okay, so from here, right, up to this point, these have been aggregator types. This is the other main type, which is not not an aggregation, it's a collector. So this would be injection. And the reason I'm handling this one next, you might be thinking like, oh, why isn't he doing joining? Because that would be all the aggregators. It's nice because I'm doing it this way. Joining comes last, but often we're joining indices that have done injection. So let's cover injection first, and then we'll cover the last mapping subtype joining last. So in this case, we're going to inject subject IDs into the category data file. So data file is going to receive these subject IDs for each either image or assay file that we have in Sheepdog. Now is a good time to pause and talk about functions that are available to all of the different either ETL mapping types, so subtypes and main types. Collectors default to set, but we do recommend here, you can see we have our function as set, which will be providing each of the unique subject IDs to the data files. So pause, mention that because it's important. As you go through the slide deck later, if you're needing it, this is here. So we want to I want to show joining props, which this one is different in that we're not directly dealing with nodes. We've put together an index already. Joining happens, very late in the ETL process. And so it's important to think of it that way. Here we've got, we're going to make an injected index where we're combining study IDs into data files and then mapping this index with events so that we end up with a join on study ID where we've got events next to our data files. So if we were to put all of this together, one of the classic ETL, almost must-dos is creating a file manifest. This file manifest would be useful on the Explorer page that in such that if you built a cohort of samples in your Explorer page by, going through each of the indices and finding, patients of a certain type that had treatments and, certain types of files that then you'd be able to download those files. To do that, you'd want the object IDs of those files. So to do that and create a file manifest, you'd first create an aggregator index that would connect subject with, let's say, demographics and sample, like you could use that nested props subtype. Then you could use a collector to inject and make an index that has subject IDs next to your file nodes, and then join those two indexes you have together to build that file manifest. To make them useful, they have to at least have that object ID. And the tip and kind of outside the scope of our discussion, but that object ID, you'd have an index D, which is another microservice that then you could call, and that would have the locations of those files that you could then interact with and download. Okay, and here is some code snippet of that, where we would create this with subject as a root, create a index that on step 2 Then we have a collector type mapping, and then join on subject ID our file index with the index we created before. There's a slight typo here, but this would be, oh no, it's not. So file, our index is file, actually should be file collector. But anyway, it would call that index and join on subject ID to create your file manifest. So I can pause for questions here. We've got a second type of example where we're looking specifically at Midric. Do we want to just launch into that second example, or do we want to pause? Does anybody need to pause here for questions, comments? We've got 6 or 7 minutes left before I hand it over to Sarah. Okay. We could take a look at Midric. We initially showed the same screen grab of Midric, but here, for the purposes of the example, we've got this cases tab, which actually has an Elasticsearch index that supports it. This is, very small writing, but we've got some, larger font here to help pull out kind of what's happening on a, and while it's nice to, have this, I won't go through each line individually. It's enough to say though, that we have, this index, Midric case, which is our Elasticsearch index called case via Guppy. And we aggregate lots of different properties under this case. So it's containing, props, which you will find specifically in case, and then aggregated props, parent, nested, and joined props from a variety of other places in Midric's ETL, all coming together to show what Midric has in way of case data in Sheepdog. Here's the sneak peek. Here's the sneak peek part. This is outside of the scope of what we're talking about, but we do have, it's good to keep in mind that, to have this all functioning, Guppy and the Explorer config need to match what's going to be happening in your ETL mapping. Once all of those are lined up though, then your exploration page will be, properly configured. So we'll have documentation on both, ETL mapping first, but and Guppy and Explorer config coming. So, and these are the examples from Midric. You can see that Midric underscore case and case that are going to be grabbing from the index we created in the ETL mapping. Okay. Now I can really pause for questions. I think up next is you, Sarah, right? Yeah. So we've got page for questions. Again, these slides will be available. I've got the code snippets that I'll save as individual YAML files. And then also it's good, once, now that we migrated to Helm, Gen3 GitOps has the ETL mappings of all the Gen3 commons that are supported by CTDS. So you can take a look through the Midric ETL mapping and the BDC ETL mapping specifically. So for, ideas and exactly how it's laid out. And those are the working examples. So they work. See, Conrad, you have a question. Oh, is it in the chat or did you want to? Oh, it's not in the chat.
We can't hear you if you're speaking, Conrad. mic's not working.
No.
Can you type it out, Conrad, or? Okay.
Okay. While he's doing that, are there any other questions, clarifying comments? Heck, you could even share general frustrations at this point, because Sarah will be going through ETL troubleshooting. So
We're really excited to see the question, Conrad.
oh, it's kind of a long one. Don't wait.
We'll have another opportunity for questions at the end. We can come back.
Yeah. Any others before I hand it over to Sarah? Okay. Sarah, did you want to share?
Yeah, I'll share my screen.
Okay. I will stop sharing it. Let you take it away.
All right. So I'm going to talk to you about troubleshooting your ETL and also the stuff that happens between ETL and when you see your data. I know that because I spend a lot of time on Gen3 Community Slack, I know that there's a lot of you who excitedly update your ETL and then run your ETL and then rush over to your exploration page to check and see, to see your beautiful data, and it's not there, or it's there, but it's wrong. And then you say, why? How can I figure this out? And we are happy to report that we figured out a guide to help you do that. And I'd specifically like to extend a very huge thank you to Joshua Harris from Australian Biocommons, who actually created the heart of this troubleshooting guide. He posted it in the Gen3 community Slack, and I have expanded on it. So thank you very much, Joshua. So first, we want to do a basic sanity check. Did you deploy the new ETL mapping? And did you make sure that you ran the ETL after you deployed the ETL mapping? These may seem like basic questions, but it's kind of like making sure your monitor is plugged in type thing, right? You would be very surprised at the number of times people get really excited about their new ETL mapping and then rush to check the data, but skipped one of these steps. That's very understandable. Data is exciting. Also, did you re-roll Guppy after your ETL run? If your indices have new data, you need to make sure that Guppy is bringing in that new data. So if you did re-roll Guppy, did you look to see whether there were any Guppy errors at startup? You can check both your Guppy and whether you're running Portal or front-end framework, you can check those logs to see if there are any errors. So for example, an error might be that you're just not getting a new portal pod because of some JSON error. Maybe you messed up the indents. Did you update your portal or front-end framework Explorer config to make sure that it is aligned with whatever changes that you made to your ETL? So assuming all of those things, you've asked all those questions and they did not help you come to a solution to your troubles. The next thing you want to do, hold on, let me move my Zoom. The next thing you want to do, right, all you people need to move too. The next thing you want to do is check your ETL and your Elasticsearch. So you can check the ETL log, and this is assuming that you're running Gen3 Tube for your ETL. As we discussed earlier, you can actually use other things to ETL, but since we're the Gen3 community forum here, we're going to assume Tube. So check the ETL log, and even though there might be lots of, dramatic warnings, if ETL says in there that it succeeded, then you can be pretty confident that it did finish. It'll say that it didn't finish, it'll say that it failed if it did. And so I've included here, if you've deployed using Helm, I've included some commands that you can run to check that ETL log. Oop. Okay, so also log on to your Elasticsearch pod and check the data there after running. So this is really useful because if you get into your pod and look at these indices, you can first of all check all of the indices that are there, right? I've provided the command for figuring that out. So you can see if there's something missing, or maybe there's like a typo in one of the index names or something. But then if you have an inkling as to which index might be the problem based on the trouble you're seeing, you can go and see the data in a specific index as well. And so these commands we've recently accumulated here, and we're very excited because we think they'll be very powerful ways to help you figure out what's going on. All right, so if your data is an Elasticsearch, then you know that your ETL is working and your data is being created. If it's not an Elasticsearch, well, what does that mean? Your ETL has a problem. Your ETL log should be able to provide some sort of clue about what's happening, because you can tell where in the logging it failed. Like it'll get to a certain point and they'll be like, no, I'm done. And so you can see where it failed by looking at what's going on around that. And so that can hopefully help you figure out what the problem is. So look at your ETL mapping, check and see if there's a typo, or maybe you have an incorrect prop name, or maybe you mistyped a path. Also, look at your data in Sheepdog, and in particular, look for special characters. So slashes and non-ASCII characters, and that's going to be particularly suspect if there's a special, like a specific data column from Sheepdog that's missing. We've had this trouble in the past where Sheepdog will accept some special characters that ETL gets real cranky about. And you can also double check that your queries that you're constructing in basically through your ETL mapping, that the path to the prop is correct, right? You should be able to use peregrine queries to get to the data that you're hoping to access. So you can test that. Okay, so assuming that did not solve your problem, let's move on to Guppy. Let's check that your data can be queried by Guppy. And so there's a couple of ways to do that. You can do that from the front end, or you can do that from the back end. So from the front end, regardless of how you're doing it, you want to restart Guppy. From the front end, you can just go to the query page. And so you can look at the Guppy schema to make sure that it's what you're expecting it to be. So there's actually a couple ways you could look at it. One is, if you really like UIs, on the query page in the upper right-hand corner, there's a little docs link. If you click on that, you can look at different indices, and you can actually look at the schema. So here we're looking at the Guppy schema for the case index. But if you would prefer not to use the UI, or at least for that, you can use the GraphQL interface. And so you can actually submit a mapping query, which looks like this. Here we're asking for the Guppy schema, the Guppy mapping schema for the case index. And so here we're seeing what it is. This is in Midrick again, by the way. So if you prefer to, sort of not do front end stuff and work from the back end here, you can get onto your Guppy pod and use curl to create a GraphQL query. So this particular one was created by Joshua Harris for troubleshooting his own challenges. And so this is how you might structure that. If your data can't be queried by Guppy, Well, that seems like the problem, right? And so figuring out why not, you can look at your Guppy logs. That should be helpful. Check your Guppy config and make sure that your index names, so that's the type in Guppy, matches up to the doc type fields in your ETL mapping. You want to check your JSON structure for problems. Don't forget to re-roll Guppy anytime you sort of make a config change to test if there's something, that maybe would fix the problem. And one last thing, back in June, we made the default setting for Guppy for the tier access level to be private. It used to be that the default was Libre, and now the default is private. And so that's just to make sure everybody's data is secure unless they would like it to be open. So you have to actively make it open or regular if you prefer. But if you didn't catch that change, then perhaps access level is what your problem is. And it's just that your data is all being hidden right now. All right. So if Guppy didn't seem to be the problem, so the data could be queried through Guppy. Let's check and see if there's something going on in the front end. Maybe the front end is using the wrong indices somehow. So you can use developer tools in Chrome to check this out. So here I've sort of given you a walkthrough where you go to the exploration page, open your developer tools, get on the network tab, etc. So eventually you're going to see like these GraphQL queries. There'll be one for each index is that right? Or maybe one for each tab, I think. And so here, in this case, I wasn't having trouble. So you can see that because all three of them are 200 status. So 200 means things are working okay. At least it made the call successfully. So it should catch your eye if it's, something other than 200. That should, help with your troubleshooting. But you can also click on them, like click on one and look at the payload. And you can even click this view source to see exactly what query is being submitted. And that should really help you figure out, what the disconnect is between what you're expecting to see and what you're actually seeing. So you can check that the index is correct, check that the query is, structured correctly. And so then you could look at all of your GraphQL queries. And so you could even, sort of pursue this troubleshooting a little bit more using the Gen3 SDK. So that's at least the beginnings of our troubleshooting guide. If you have other troubleshooting tips, boy, we are interested in hearing them because we would like to make this community guide for everybody. But final thoughts about troubleshooting is that, as Dan mentioned, you can go to see all the examples that we have available in our Gen3 GitOps repo. And I've specifically added links to Midric examples and Gen3 Data Hub examples, where I've linked to the ETL mapping and then the Guppy indices, and then the Explorer config and the Guppy config. So both of these are actually part of the Explorer config. And then I've also linked to the exploration page on the Midric platform or on the Gen3 Data Hub platform so that you can see how each leads to the other without having to see tiny, tiny text on our screen. So you can go and check it out yourself. And with that, I think we are ready to take some questions. And I think there are some in the chat. I might stop sharing. And Michael, do you want to share?
Sure. Well, let's just start with that first question, I guess. You can stop sharing though, Sarah, if you like. I think that first question was aimed at Dan. Conrad typed his question in. Do you want to start with that, Dan?
Yeah, essentially the first question, if I was to summarize it, is where do these mapping names come from? I know they're specified in tube, but I'm not sure if they are Gen3 specific or if they have an origin in some other language. So I didn't develop the ETL mapping or tube specifically. That'd be good for somebody who's been around a bit longer, Mingfei or Chris. Where do those names come from? And can we do additional reading on them?
Or Alex, I see you're on the call if you know the answer to that either.
So the names of
So like parent props or flattened props, those names, do those come from a specific place external to Gen3? Are those internal and kind of created for our own purposes inside Tube?
oh, that's just for tube, right? Because tube reads the ETL mapping file as basically you can think that's as of the configuration of it. So that's what tube is expecting to see. Then tube will know, oh, for these fields, I need to treat them as nested props or flattened props or whatsoever. But it's really just what tube needs.
Okay. So we've kind of invented those names as an understanding inside the Gen3 platform. And it doesn't trace back to another either query language or indexing schema.
Yep.
Okay. Sorry, Conrad, we're going to be the ones writing the documentation for you to do your further reading. I guess sorry, not sorry. We're going to do that.
Yeah. There's another question by Carvin. I can read it. In ETL Helm chart, there's an argument ETL forced. By default, the value is true. That will let the ETL job run. Then after multiple running, the ETL job will raise an error about indices reach limit. There's a cron job. If I enable it, will it solve the issue above? Could you please help me to understand it? Dan or Sarah, do you have any insight into that, or can
My insight is to call upon perhaps Alex or Mingfei. Do you guys have any thoughts about ES garbage collect and whether that could help Carvin solve his problem with the limits he's seeing, the error about indices reaching the limit?
I believe it should. As for what I'm recalling correctly, I have to make this like disclaimer sort of announcement before because I haven't checked the code of that part for a while, but I believe what we used to have at least the ES garbage collect job to do is it's gonna in the first of all, in the setup of Elasticsearch, there are aliases and there are Elasticsearch indices. The indices is what every time tube ETL will produce, like the tuber will produce a new indices or a set of new indices based on the ETL mapping after the successful ETL. But then because you definitely don't want to change Guppy config to point that Guppy to a new indices every time. So we have the Elasticsearch aliases, which you have an alias, but the alias is actually pointing to a specific index. And then after Cube does the ETL, it will update the pointer from the existing alias to the newly created indices. So that's how and you feed Guppy with the name of the alias. This how basically that works. So that will left some orphan indexes in there from time to time, and that is exactly what the ES garbage collect job should be doing. Like it should just go in there, find out which index that the alias is currently pointing on, and the rest of the indices are, will consider to be orphan and will be garbage collected. I think that's what it is doing. I don't know if, like, I cannot recall at this particular moment if it has more sophisticated logic in there in determining which index should be garbage collected versus which should not be. But I mean, essentially, it will or it should clean up some garbage from there, and free up the elasticsearch basically, a bit at least. And also I should say I have not actually tried. I know we have a configuration field in the Helm chart to enable this ES garbage collect job, but I personally haven't tried to enabling that in there intentionally and see how it works. Maybe someone else may from the Gen3 team may have other experience, but it's just I personally don't have that experience. But assuming everything works, it should just do that trick.
Thank you. I will practice and test more about that issues, and then, yeah, maybe I'll raise more questions. Thank you.
Yeah, I think we can definitely note this down and try it ourselves, and gonna spread the word out to the community.
Sure.
More questions. Are there any other questions from the listeners that you can either type in the chat or feel free to unmute? Sarah, this is up your alley. Do you have a response?
I do. So the flag for me is I'm getting the string cannot represent value error. And so my question is, have you set a function for these submappings or the fields, I guess, the props?
I believe I was using either the parent properties or the nested properties. So I did not set like the functions.
So we have observed that often if you use the function of set, that will frequently fix this error. I have more information about it in my notes, or possibly Mingfei can say so off the top of his head. But let me grab my notes real quick.
Yeah, I'll just make a quick comment. Obviously, I haven't seen exactly what the error you are seeing. So this is more like a comment that comes out from my just comes out from my guessing. But I think it might relate to the fact that, actually, first I should ask, do you know if you have a array field in the nested field?
Sorry, what in the nested field?
Do you know if you have an array field in the nested field? Like, is there a array nesting in there?
No, but I think so I have one to many relationship. from like the parent node to the children node,
Uh-huh.
there will be many children. I think that might be considered as like an array. Not quite sure though.
Yeah, if you have access to the Elasticsearch service that you have on your side, you probably could just go there and check your raw data and see uh, see how it represents in the array in the sorry in the indexes that got stored on Elasticsearch. I highly suspect that this is related to a known issue with regard to how Guppy handles uh, nested array fields. Uh, we are working on a fix on the Guppy side to resolve this issue. It's currently being testing, and hopefully we can uh, release that soon. We may need also to put some fix on tube side. We're still testing if we need more fix on other service. But at the end of the day, I think this might be related to a issue that or a bug that we are known of, and we're very close to having a fix out available.
Oh, okay. Thank you.
Yeah, so my suggestion right now would be you can double check if you have a array field nested in the fields. If you do, it's just very likely that you got hit by the bug, and we're gonna fix it.
Yeah, so like if I have like multiple values, then is it considered as an array?
Uh, Most likely it will. It will depend on if you use any special aggregation function on it. Like if you use, like we mentioned, there's a couple of aggregation function that a tube will take. Like for example, there's something like sum or count. If you use those functions, it will just give you a number instead of put an array in there. But some other functions like I believe set will just give you a array, or if you don't put anything in there, if there is a one to many relationship, that usually will end up with an array.
Oh, okay.
Is it possible to use sorted by in parent props? Or is that a flattened props only?
Uh, I really want to say I know, but I don't know. So sorry, I need to get back to you on this in the future.
Shinchen, I found your query in Gen3 community, and Mingfei, Sarah, Dan, I forwarded it to you. We can make sure to take a look again. Thanks for your question right now, but just to refresh our mind and look back, because it references another thread which is quite long as well, and so we might need to take a bit to take a look at it. But thanks for bringing it up again.
Yeah.
Maybe at this point we should send a big thank you to all the people in the Gen3 community Slack who have been sending us ETL questions to inspire this presentation. We appreciate it.
So Shinchen, I think what Mingfei says stands, but we'll take a look again and get back to you, see if we can offer some more help there.
Okay. Thanks for taking another look on it.
Were there other questions? Oh, can we get the
Can we
PowerPoint
get the
file?
PPT?
Yes. Well, oh, the PowerPoint, maybe it'll be a PDF. We'll make sure that the links are all I guess, that you can click on it, I guess. Maybe PowerPoint or PDF.
Yeah, if you need like the slides because you'd like to incorporate it into a presentation of your own, just let us know. I think usually we share them as PDFs.
Okay, thank you.
Any other questions? These are great, by the way. Oh, sorry.
I have a request, not a question. I already put it in the chat, but in case you didn't see it, I know that, so this particular presentation was especially targeting people who are struggling with their ETLs, but I know that there's like ETL power users out there. And we are very much interested in, well, whether you're a power user or not, if you've got like, oh, I know when I need to do this to get my ETL to work, or here's how I like go about doing this special troubleshooting. We would love to hear those tips and tricks because, as I say, we're really trying to beef up the documentation on ETL, and we'd love to include, you know, your resources as well. We're, of course, happy to like credit you in our documentation for providing knowledge. So please feel free to email it to us. You can send it to support@gen3.org, or if you prefer to Slack it, you can Slack it to us. But we'd love that.
I also want to just call out if there's any other CTDS user services or developer on the line that, you know, if there's some like particular thing that you think might be helpful for the community that didn't come up today, you know, feel free to volunteer that information now. I mean, I think we've already tried to make sure we caught all that, but just giving everybody the opportunity to volunteer that if they had anything. Okay. Sarah or Dan, do you have any closing comments?
Thanks, folks.
Yeah, thanks for bearing with us. I know it's a bit of a different format than normal. The very Gen3 heavy.
Yeah. Okay. Well, special thanks to Sarah and Dan for putting this all together and for the contributions they got to beef it up. Thanks a lot. We don't know for sure what the next forum is. I have some ideas, so if anybody has some ideas that's online, please let me know and we can see if we can put that into an upcoming forum. So with that, thank you so much, everyone. We'll talk to you again soon.
Thanks, everybody.
Thank you.